Welcome to another web lecture for Civil Engineering Systems. Hopefully this will be the last web lecture of the semester and that we will be returning to the in-class format on October 26th. This week's lecture concerns schedule optimization. In last week's lecture we learned how to develop a project schedule and create durations, start times, and finish times for multiple tasks. With schedule optimization, we will learn how to manipulate the schedule in order to balance the costs and the resources involved with each task. So we will be discussing two tools, resource leveling and crashing. Resource leveling is essentially the process of shifting tasks forward or backward in time such that the resources associated with overlapping tasks don't accumulate. Lots of times you see projects where there are multiple crews on site all at once, and then a few days later most of them are sitting around on downtime. And this is because they can't continue until, say, another task is complete. Equipment like the drill rig shown here cost money just to mobilize and demobilize them to and from a site on top of their daily rental rates. So you want to make sure that they only have to mobilize to the site once, and that once they are on site, that they are fully utilized. It is important to know that tasks on the critical path, referring to the arrow diagram, the critical path cannot be shifted for resource leveling since there's no float to allow you to shift them. It is also important to be aware of shifting the timelines of tasks as to not create a new critical path. So let's take a look at our geotechnical investigation schedule that we looked at in the last class. Now, in order for this example to work, we're going to have to add an additional field task. So here we've added the CPT field testing task. Now what CPT is, it's a type of geotechnical investigation that's done in the field along with the concrete sampling and the soil sampling. The difference is that the CPT testing doesn't collect any samples, so there are no sampling tests that have to be done after the CPT. It is also projected to take 5 days to complete. So if we look at the arrow diagram we created in the last class, we need to make an adjustment to fit in this new task. We add task 2.5 for the CPT test with a duration of 5 days. Now task 2.5, like I said, doesn't return any samples, so there's no sampling task that's dependent upon it. However, it's still needed to be performed before task 6.7, the report writing. So we draw this dashed arrow to show that while there is no task 5.6, but event 5 needs to happen before event 6. So we set up a Gantt chart from our arrow diagram. And the way we set up a resource leveling is that on our Gantt chart we place a column with resources for each task. In this particular example, each task requires just one resource or person to complete each task. The next step is that along the x-axis, we will add up the number of resources used in that particular day. So for the first 4 days, only one resource is being utilized because only one task is occurring. So for each day, we put a 1. When you add up the resources in days 5 through 9, we find that we need 3 resources, or 3 people, in those days, because we have 3 tasks happening at the same time, each with 1 resource needed each. After the CPT testing concludes, we only need 2 resources for the next 25 days. After the concrete sampling ends, the concrete testing begins, so we still need 2 resources. After the soil sampling concludes, the soil testing will happen alongside the concrete testing for a time. We will need 2 resources during that time. After the concrete testing concludes, we are left with just 1 resource being utilized. And finally, we have 1 resource for the 3 days of report writing. So, what can we do to level the resources to make sure that we can involve as few people as possible? Well, we know that the utility survey, soil sampling, soil testing, and report writing are all in the critical path, so we cannot move any of these tasks forward or backward in time. So that leaves us with the concrete sampling, CPT testing, and concrete testing to be shifted. The goal here is to reduce the number of resources from 3 to 2 during these 5 days. We could shift the CPT testing to the end of the concrete sampling, but then we would still have 3 resources being utilized with the start of the concrete testing. So let's look at shifting the concrete sampling. We see that when we move the concrete sampling forward in time, the concrete testing task must also move forward since it is dependent on the sampling task. You can also see that moving it forward 5 days like we have is as far as we can go without altering the duration of the project and thus creating a new critical path. Now, you see we have reduced the numbers of resources from 3 to 2 during these 5 days, while increasing the resources from 1 to 2 for these 5 days. Now that we have done this, we now only need 2 people to complete this project. The second tool we're going to look at is crashing, and it is a relatively simple method of analyzing if it is beneficial from a cost perspective to reduce or crash the duration of a task. The first thing you look at are what are called the indirect costs, which are the costs associated with the normal daily operation of a task. For example, the daily rate of laborers, equipment rental, project management, and things of that nature. These are costs that you will be saving by reducing the duration of the task. Compare this with the crashing costs, which are the costs associated with reducing the task. So these would be the overtime rates for the laborers that have to work longer days, the use of additional equipment and additional crew. So the difference between these costs will determine whether or not it is beneficial to crash this task. So let's look at our original scope without the resource leveling. If we reduce a task on the critical path, we can shorten the overall length of the project. So let's look at shortening the length of the soil sampling from 40 days to 35 days. This brings the soil testing backwards in time 5 days. And it also brings back the last task, report writing, and overall due date from 57 days to 52 days. So let's look at the costs associated with this reduction. We figure that in order to reduce the duration of the task by 5 days, we will need to ask the crew to work overtime for 10 of the days. We will also need to bring in an additional rig. So by reducing the duration 5 days, we will be saving on paying the drill crew for 5 days. We will also save on renting equipment for 5 days and paying the inspector for 5 days. On top of that are all of the miscellaneous expenses and project management that it will cost over those 5 days. We determine that the cost of working normally for 5 days is $38,250. Now, in order to reduce the task by 5 days, we will need to pay the drillers overtime, pay for an additional rig, and pay the inspector overtime. This comes out to a crash cost of $29,000. So, looking at these two costs, we can determine that the cost savings of reducing the number of days in the task from 40 days to 35 days actually works out in the favor of crashing for a total savings of $9,250. So that concludes this week's lecture. It was a short one, but important material nonetheless. Now, please email me if you have any questions with regards to this lecture or any homework assignments. Next week, I will be sending you an email with your first exam. This will be a take-home exam that will include linear programming, engineering economics, project scheduling, and scheduling optimization. So basically, the test will include everything up to and including this lecture. It will be due in the following class, which will hopefully be in class. This is October 26th. Thank you very much. Have a nice week.